Welcome to Sigma Solver guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So without any further ado, let's get started. Today we are going to look at a new problem, Lagrangian interpolation. Given 4 sample points 1, 1, 2, 4, 4, 2 and 6, 5 for a Lagrangian interpolation curve, find out 5 points on the corresponding interpolation curve so that we can scan convert it. So first we will understand what is interpolation. Lagrangian interpolation is a method that we use to identify points within a given data range so that we can complete the curve. Better, we use a polynomial to approximate a function within a given range of data points. So if we see for an example, so we are given, let's say, 5 points in this particular curve, and we are also given that the function has a degree 2. By using this method, we can approximate these points which fall in between the first data point on the x-axis and the last data point on the x-axis. We can approximate any one or more of these points, but they will lie in between these, right? So it will fall in between these two data points, interpolation, right? But let's say we wanted to find out something outside this range, then that would be called as, let's say we want to find out here. So if we try to find out here or here, that will be called extrapolation, right? So this is a major confusion. So I tried to clear this up, that what is extrapolation and what is interpolation. So all the green dots that you see are extrapolated out of this function. So now let's continue with our discussion. So we can have different ways of implementing Lagrangian interpolation. So let's say if the polynomial that we are analyzing is of order n, then the function that we are expecting will have something expressed like this: x minus x1, which is the second point which we are given, x minus x2, the third point, up till x minus xn. And here you see x0, this is the first point, that is x0, y0 is the first point that we are given in the question. So this is that minus x1. Of course, there will be no x0 minus x0, otherwise it will turn 0 in the denominator, and then so on and so forth up till here. So this is going to be the coefficient for the first term multiplied with the output, that is y0. This is C1. Now the second one will be x minus x0, x minus x2. So you see, in the first case, the first term, that is x minus x0, was missing. In the second term, x minus x1 is omitted. So that's how you need to proceed. And similarly, x minus x0, x minus x2 up till x minus xn. So in the denominator, the x1 or the minuend is like the second term, and that is followed all along, x1 minus x0, x1 minus x2, and so on, right? So up till the last part, numerator will not have x minus xn, we have to continue, and below xn minus x0 will be followed up till xn minus x of n minus 1. And this is the target function that we want to approximate. So this is the target function. Okay, so this was for if the polynomial is given to be of order n. But if it is of order 1, that is of type ax plus b, then we have fx is equal to x minus x1, x0 minus x1 into y0 plus x minus x0 into x1 minus x0 into y1. Simple, it's just the miniature version of what we saw above. Simply, if we have, let's say, of order 2, that is ax square plus bx plus c, then it will be of this type: x minus x1, x minus x2, It's just that we omit the first term in the numerator and make it the minuend in the denominator. So that's how we proceed. Now let the given polynomial which is in the question to be of order 4, right? It's not because like there are 4 points in the question, I've just taken it to be 4. You can take it 3 or 2 and then do it accordingly. It will be just that the first 3 terms or 2 terms that we find out will form the coefficients and the rest of it is not needed. It is also obvious that if we are given, let's say, 3 points, we cannot have interpolation for a 4 order polynomial using that. It doesn't make sense, right? So now if we start finding the coefficients, so if the order is 4, then the polynomial will look like, so this will be the polynomial, and so this will be the coefficients of it, right? This one, and this one all together. So if we just put the values, so we had these coordinates 1, 1, 2, 4, 4, 2 and 6, 5. Then we will have this particular equation, right? We just simply put the values from here. This is simply put them. We'll find these out, and then once we are like solve this equation, then we'll end up with the actual function that we want to approximate and use in interpolation. So in this we can put the different values, let's say 1, 2, 3, 4, 5, and find the corresponding values of the function, right? So but then again we must remember that we have taken 1 as the lower limit and the 6 as the upper limit, so the values should be in between them for interpolation. So that's been it. If you still have any doubts, then feel free to reach out in the comment section below. If you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving.
Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.